Share this one. Badhiya, can you hear me? Is everyone there? Hala, are you there?
Yes, sir.
ठीक है. अच्छा चलो ठीक है. Let's start. Yesterday we started with entropy, and I told you that entropy was basically disorder. If something is very disordered, I told you that's high entropy. If something is not very disordered, that means it's low entropy, right? The symbol for entropy was S. I didn't tell you the unit. I mean, the unit for entropy is joules per Kelvin per mole, but we are going to discuss that when we start calculations. I said there are two more people joining in just a second. Actually, we. I said so it was disorder of the system, and I told you that if your delta S is positive, then that means the disorder is increasing, right? Vice versa, if delta S is negative, that means disorder is decreasing. And I told you, I gave you examples. I told you that you have an untidy room, that's a high entropy state. You've got a neat and tidy room, that's a low entropy state. So if you go from low entropy to high entropy, your entropy or disorder is increasing, right? And vice versa, that means delta S, the change in entropy, is positive. Vice versa, if you're going in the other direction. Hold on 1 second. So vice versa, if you're going in the other direction, that is delta S negative. That means the entropy is decreasing. एक सेकेंड में दिया वो तरीका. So your entropy decreases. So high entropy and low entropy, delta S positive, gain in entropy, delta S negative, loss in entropy. And I told you, okay, delta S positive is very easy. Delta S positive is making your room untidy is easy. Going from high entropy to low entropy, that is difficult. So things, they naturally move towards delta S positive. They all like delta S positive. You buy a new car, the car gets broken down eventually. Things always prefer high entropy state. That's known as your stable state. A high entropy state is very, very stable. I mean, if you have a broken car, a very rundown car, that will maintain its state. It will even gain further entropy, right? But a low entropy state, a neat and tidy state, that's a very unstable state. Things, they don't prefer that state. ठीक है, तो यहाँ पे मैंने I gave you examples. So your low entropy state over here, this state over here is a very unstable state, because no matter how you're going to shake this beaker or jar, it will eventually gain entropy and it will go into a disordered state. And no matter how many times you shake this jar over here, the high entropy state is going to maintain its state. It will gain further entropy, but it will try to maintain. So your untidy room will try to maintain its state. Your neat and tidy room, it never tries to maintain its state. It always tries to go into a high entropy state. Okay? So how is that related to chemistry? Okay, I told you that delta S positive is something that every system on planet Earth, it likes. Delta S positive is a universal law that applies to the entire universe. The universe likes things to be disordered. It does not like ordered things. So we're going to talk about, I mean, the first thing is we're going to talk about it in qualitative terms. So chemistry and how is it linked with delta S? Now, the first thing is you've got all these chemical reactions happening. These chemical reactions are basically systems that are either gaining entropy or disorder, or they're losing disorder. So starting with the first thing, how to predict by just looking at equations whether your delta S is positive or whether it's negative. How are you going to predict that? So the number one way you're going to predict whether delta S is positive or negative, that's you're going to look at the states. So for example, I've got solid. So change of state. Look at change of state, and you'll figure out whether the system is gaining entropy or losing entropy. So change of state from solid, if you move to a liquid, and from a liquid, if you move to gas. So that all is delta S positive. So when that happens, the system is gaining disorder. TK, clear? This is obvious, right? Is that clear? Yes or no? Is that clear?
Yes, sir.
TK. So solid, the particles are really neatly, tightly packed. अच्छा, liquids में they're kind of loosely packed and slipping and sliding. So slightly more entropy. And in gases, the particles are like really far apart. And they're all flying in different directions. So that's high entropy. So what I'm going to state over here is, so this one is obviously your very low entropy state. Now, the difference between disorder between solids and liquids is not that much. So this thing over here is slightly higher, just very slightly higher entropy. While when it comes to gases, that's very, very high entropy. Okay, so if you go from, so you have to keep this in mind, that the difference between disorder in a solid state and a liquid state, it's not that much. But when it comes to a gas, then it's very, very high disorder. So if I were to plot a graph for this, and they might ask you to sketch a graph. As I say, if I sketch a graph of ice, which starts at let's say starting at minus 50 degrees centigrade over here. So this axis over here is temperature. And so this is minus 50. Then it reaches, let's say, 0 degrees centigrade. And then after that, it reaches 100 degrees centigrade and so on. And on this axis, I've got I'm calculating the entropy of the system. And this is, we are plotting it for ice. So this is S for H2O. Now, right at the beginning, at minus 50, it's a solid. So that is very low entropy. Now, whether ice is at minus 50 or ice is at 0, the difference there's going to be a slight gain in entropy. Okay, now listen to this carefully. Ice, whether it's at minus 50 degrees centigrade or whether it's at minus 25 degrees centigrade over here, it still is ice. The ice particles are still tightly packed. So the disorder is not that much. There's a very हाँ जी
सर आपने कहा कि माइनस 50 डिग्री सेंटीग्रेड से 0 डिग्री सेंटीग्रेड तक वो आइस वो वाटर जो है वो आइस स्टेट में ही होगा, तो मतलब ये माइनस 50 से 0 तक जो है मतलब थोड़ा बहुत भी इसके पार्टिकल्स की मूवमेंट में चेंज नहीं आएगा, ये जरा क्लियर कर दें।
नहीं ये मैंने कहा थोड़ा सा आएगा, बहुत थोड़ा, ठीक है। मतलब वैसे देखने में क्या आएगा, बहुत ही मिनिमल सा फर्क आएगा ना पार्टिकल्स में, डिसऑर्डर में। मतलब आइस माइनस 50 पे है ना, और आइस माइनस 10 पे है, अभी भी वो आइस ही है ना, तो ऑलमोस्ट नेग्लिजिबल होगा। हाँ, थोड़े बहुत पार्टिकल ज्यादा एनर्जेटिक होंगे तो थोड़ी बहुत लेट्स से पार्टिकल्स की वाइब्रेशन ज्यादा हो जाएगी, तो बहुत ही मामूली से ना डिसऑर्डर में चेंज आएगा। ठीक है, क्लियर है मदिया, इज दिस क्लियर?
यस सर।
तो यहाँ पे मैं लिख भी देता हूँ, ऐड कर देता हूँ, कोई खास तो इन दिस, इस जगह पे ना आइस रिमेन्स इज सॉलिड, तो वेरी minimal सा change in disorder. Particles become more energetic. अच्छा, लेकिन उनका डिसऑर्डर का कोई खास फर्क नहीं पड़ रहा। अच्छा, जीरो पे जब चेंज ऑफ स्टेट होता है ना, देन ऑल ऑफ अ सडन लिक्विड स्टेट में वो कन्वर्ट होता है, तो देयर इज गोइंग टू बी अ वेरी नोटिसेबल चेंज इन डिसऑर्डर। और लिक्विड से ना यहां तक ये तो सीधी होगी, एक सेकेंड, एक सेकेंड। अच्छा अच्छा, लिक्विड के अंदर भी ना, तो यहाँ पे सॉलिड था, और 0 to 100 ना इट्स नाउ अ लिक्विड। तो नाउ ऑब्वियसली जब वो मेल्ट करेगा ना, there's going to be a noticeable change in disorder, right? Liquid particles are more disordered. लेकिन if you have a glass of water that's at, let's say, 10 degrees centigrade, and you've got the same glass of water at 80 degrees centigrade, तो देखने में उनके disorder में क्या फर्क होगा? It's still going to be liquid water, right? तो the particles are not going to be there's not going to be a huge change in disorder. हाँ, थोड़ा बहुत increase हो रहा होगा, particles are becoming more energetic, but overall वो जो लिक्विड है ना, that still remains liquid.
सर
हाँ जी,
सर ये जो आपने 0 डिग्री सेंटीग्रेड से ऊपर जो एक ब्लू कलर की लाइन वर्टिकल जो ड्रॉ की है, ये क्या शो कर रही है? ये चेंज ऑफ स्टेट शो कर रही है?
हाँ, चेंज इन डिसऑर्डर शो करेगी।
ओके सर।
देखो 0 डिग्री सेंटीग्रेड पे वो मेल्ट हुआ है ना, तो जब वो सॉलिड आइस था तो मेल्ट, उसकी एंट्रोपी कम थी। जैसे ही वो लिक्विड में चेंज हुआ, एंट्रोपी क्या होगी है, ज्यादा होगी है। इज दैट क्लियर? ठीक है, ठीक है। अच्छा, अगला नेक्स्ट पार्ट। नाउ 100 पे क्या होता है? व्हाट हैपेंस एट 100? नाउ एट 100 इट चेंजेस इनटू अ गैस। अच्छा, व्हाट्स गोइंग टू हैपन ओवर हियर इज देयर इज गोइंग टू बी अ ह्यूज चेंज इन डिसऑर्डर। मतलब अगर कभी भी पानी को बॉईल किया ना, you would have noticed कि all of a sudden at 100 it turns into steam and there's a massive change in disorder, ठीक है? तो there's going to be, इसको नीचे करना है. अच्छा, so there's going to be a massive change in this order. इस point पे 100 पे. Plus another important thing is कि all gases, उनका जो disorder होता है ना, it doesn't remain the same. Steam जो है ना, if it's at 100 degrees centigrade, let's say 101 degrees centigrade, and if you have steam at 10,000 degrees centigrade, तो दोनों के disorder में ना there is a massive difference. ठीक है, particles in steam at 10,000 degrees centigrade, those are going to be very disorderly. ठीक है, तो gases के अंदर ना disorder doesn't remain constant. Liquid और solids में ना the disorder kind of, उसमें temperature से कोई इतना फर्क नहीं पड़ता. ठीक है, liquid के अंदर ना temperature ये हो या ये हो, वो जो glass है ना पानी वाला, it remains kind of the same, right? The liquid kind of remains the same. Ice doesn't really matter if it's at -10, if it's at -50. There's very little negligible change in disorder. लेकिन गैस के अंदर क्या होता है कि disorder increases. ठीक है, why does it increase? Because और ये पहले मैं ऐड कर लूं, why does it increase? Steam at 10,000, मतलब यहाँ पे मैं लिख लूं, पॉइंट किया था, huge change in अच्छा, so उसकी रीजन मैं बता रहा हूँ कि what happens in gases is, in gases the entropy increases with temperature. अच्छा, टेम्परेचर को मैं कैल्विन्स में ले रहा हूँ, आगे जाके ना वी हैव टू कन्वर्ट इनटू कैल्विन्स. अच्छा, इन गैसेस एंट्रोपी इंक्रीजेस विद टेम्परेचर. व्हाई? बिकॉज गैसेस कैन एक्सपैंड. ठीक है, सो बिकॉज गैसेस एक्सपैंड विद टेम्परेचर. अगेन टेम्परेचर को कैल्विन्स कर लें, and they become even more disordered. तो लिक्विड और सॉलिड्स थे ना, दे डोंट एक्सपैंड. सॉलिड वहीं के वहीं रहते थे, लिक्विड पार्टिकल्स इकट्ठे ही रहते थे. बट व्हेन इट कम्स टू गैसेस, गैसेस एक्सपैंड. तो गैसेस का जो ग्राफ होगा ना, इट्स जस्ट गोना गो अप. टेम्परेचर इंक्रीज करते रहोगे. स्टीम एट 101 एंड स्टीम एट 10,000, ह्यूज डिफरेंस इन डिसऑर्डर. ठीक है, इज दैट क्लियर?
यस सर.
हालांकि दिस क्लियर बताइए. ठीक है, अच्छा, there's going to be a huge change in disorder. ठीक है, keep this in mind, and keep this in mind कि the highly disordered state is gases basically, and gases at height,
सर.
जी जी,
सर आप कह रहे हैं ना कि सॉलिड्स और लिक्विड्स में एक्सपेंशन नहीं होती ना, तो अब जैसे फॉर एग्जांपल इफ वी आर टेकिंग द एग्जांपल ऑफ एनी मेटल, तो हमारे पास कोई भी मेटल हो, ठीक है, वो सॉलिड स्टेट में होता है, तो हमारे पास एक्सपेंशन होती है, मेटल्स में एक्सपेंशन होती है, तो
नहीं नहीं,
जिससे हम
वो नेग्लिजिबल है ना.
अच्छा.
मतलब एक मेटल, मैं वो चूल्हे के ऊपर ना मैं वो चाय बना रहा हूँ, तो
जी.
मतलब तो नेग्लिजिबल है ना, यू कैन जस्ट. ये जो थोड़ा सा
ओके.
जो थोड़ा सा बना हुआ है ना, ये जो थोड़ा सा ऊपर जा रहा है, ये उसी वजह से बन रहा है. जो आपने बात की है ना, लेकिन वो नेग्लिजिबल है, स्टिल नेग्लिजिबल. ठीक है, बल्कि मेटल्स का अच्छा एग्जांपल है कि यू टेक अ केटल, राइट, उसको आप 1000 डिग्री सेंटीग्रेड पे भी ले जाओ, डिसऑर्डर में क्या चेंज आता है? कोई खास चेंज तो नहीं आता ना. मतलब वो एकदम से फट तो नहीं जाता, मतलब एक्सप्लोड तो नहीं करता ना. अगर प्रेशर कुकर है, उसमें स्टीम है या पानी है, तो मतलब वो प्रेशर कुकर से एक्सप्लोड करते हैं. ठीक है, व्हाई डू दे एक्सप्लोड? पानी अगर वो आइस की फॉर्म में होगा डिसऑर्डर में कोई खास फर्क नहीं होगा, लिक्विड फॉर्म में होगा फिर भी डिसऑर्डर में कोई इतना खास फर्क नहीं पड़ेगा। स्टीम बनता है तो एकदम से डेंजरस हो जाता है, फिर डिसऑर्डर बिकम्स, मतलब बहुत ज्यादा डिसऑर्डर बढ़ना शुरू हो जाता है। तो व्हाई डू प्रेशर कुकर्स एक्सप्लोड? क्योंकि क्योंकि गैस है ना, गैस creates a lot of disorder. Is that clear?
Yes, sir. It is clear now.
तो हाला, is this clear? बाकियों clear है? साइमा?
Yes, sir. It's clear.
Okay. अच्छा, keep this in mind. बल्कि basically इस पूरे उसमें ना, what you need to keep in mind is gases have a lot of disorder. Keep that in mind. अच्छा, so second point, either change of state. ठीक है, you figured out if states are changing. Second point is if in a chemical reaction, so if a reaction produces more gas moles, then that means delta S is positive. But as an example, if I give you a reaction and I tell you that Mg and HCl are reacting and they're producing NgCl2 plus H2 gas, right? I say reaction here. This is a solid. This is aqueous, and gas. Achha, now the question is, how many moles of gas do you have initially? 0 moles of gas. So how many moles of gas do you have after the reaction? 1 mole of gas. So that indicates disorder would increase. ठीक है, वो करके देख लो Mg, if you put it in HCl, because the gas is getting produced, you would see disorder getting produced, right? तो इसका मतलब है delta S is positive. Is that clear?
Yes, sir.
Similarly, if you have a reaction in which all of them are gases, or let's say forward है, ठीक है, ignore the backward reaction for now. So how many moles of gas do you have initially? You've got 4 moles of gas. और बाद में कितने? You've got you got 2 moles of gas. तो इधर क्या हुआ है? Delta S, less gas is getting, more gas is getting converted to less gas, right? So that means delta S would be negative. Is that clear?
Yes, sir.
Yes, sir.
चलिए, बाकी मेन तो यही है, गैस से रिलेटेड है, but the other ones you have, let's say number 3. Okay, we've got let's say सारे के सारे, all of them in aqueous state, ठीक है? If state remains the same, and there are no gases, right? So if मतलब वही है, number of particles increase, उसका मतलब है delta S is positive. You're going into a more disordered state, and vice versa. तो एक एग्जांपल दे रहा हूँ कि I've got NaOH plus HCl, and it produces NaCl plus H2O. ये सोच के बताओ, is this all of them? This is aqueous, ये भी aqueous है. अच्छा, so the state is kind of the same. मुझे बताओ कि is this delta is positive or negative?
No effect, sir, no effect.
शुरू में कितने particles है, बाद में कितने particles है?
Equal.
अच्छा नहीं, अच्छा भाई, अच्छा basically in this case you have to look a little deeper. Deeper ये कि शुरू में ना it's actually 4 particles. से क्या होगा? अच्छा, शुरू में it's actually 4 particles और बाद में it's actually 3 particles. ठीक है? The reason it's 4 particles is कि NaOH aqueous is actually dissociated particles, Na+1, but the ions are just roaming around, right? ये clear है ना? Ionic compounds, when they are aqueous, the ions are dissociated. They're floating around separately. ठीक है? HCl aqueous का भी वही मतलब है कि it's H+1 plus NaCl aqueous. That also means dissociated, right? अच्छा, H2 is a liquid. So it's actually, I mean, what the reaction that's happening is that the H+1 and the OH ions are combining.
Sir,
And they,
entropy is negative.
हाँ, तो 4 particles. And now you have 3 particles. इसका मतलब है delta S would come out to be negative. ठीक है?
So, sir, it means if we are having a reaction in which there is a liberation of gas, so we check the number of moles. And when we are having an equation in which the reactants and the products are in the aqueous state, so we are looking just for of ions they are producing.
हाँ वही बिल्कुल ना, वो
equation.
बल्कि इसमें जो पॉइंट था ना इस वाले पार्ट का, वो ये था कि always be careful with ionic compounds. अगर NaCl solid लिखा हुआ है ना, that's one particle. और अगर NaCl aqueous लिखा हुआ है ना, that's actually 2 particles. ठीक है? Is this clear?
Yes, sir, it's clear.
So be careful with ionic compounds. अच्छा, और क्या कि बाकी वैसी है कि let's say dissolving substances, वो तो खैर ऑब्वियस ही होगा कि अदर एग्जांपल्स वैसे ही कर लेते हैं. So for example, you've got NaCl solid and it turns into NaCl aqueous, बल्कि पिछले से लिंक्ड है. तो एक तो वो change of state है, that's why the disorder is obviously increasing, but the actual equation looks like this. It's NaCl solid, which has turned into Na+1 dissociated aqueous ions. So that's why delta S is definitely positive. ठीक है? Decomposition, obviously that's a gain of disorder. तो हम यहाँ पे ना मैं यहाँ पे I'm going to share the worksheet now. एक सेकंड मेरा. Let me open the worksheet. कहाँ गई है? Just give me 1 second. मैं ग्रुप पे व्हाट्सएप कर रहा हूँ. ग्रुप पे आप लोगों का 1 सेकंड. ठीक है. अच्छा मैंने ग्रुप पे व्हाट्सएप कर दिया, तो बस ये ओपन कर रहा हूँ ताकि एटलीस्ट ये वाले क्वेश्चंस हम कर लें. अच्छा, so we'll just focus on delta S being positive or negative. That's it. तो आपको ना, and the questions are going to be pretty basic. तो starting with ये बताओ, वो पूछ रहे कि why is the delta S for reaction number 1 positive? तो क्यों है positive? I mean, look at reaction number 1.
Sir, make it closer.
ये भी सही है.
Yes, sir.
हाँ, ये why is delta S positive for this reaction?
Sir, can I answer?
हाँ जी, बताइए.
Sir, if you see the reaction on the reactant side, both exist in the solid state, right?
ठीक है,
And
solid.
on the product side, sir, but it is written silicon in the liquid state.
हाँ, liquid is liquid.
We have 2 moles of carbon monoxide that exist in the gaseous state, and you have you told us that के number of moles जो हैं यहाँ पे हमारे पास 2 हैं, because so that's why the entropy for the above reaction is positive.
ठीक है, number of moles of gas
Yes.
increase.
Increases. Number of moles of gas on the product side, it increases.
ठीक है, on product side. So delta S, ठीक है, क्लियर है. तो इस तरह के छोटे छोटे क्वेश्चन, ये बाकी अभी हम स्किप कर रहे हैं. एक सेकेंड, डेल्टा एस वाले क्वेश्चंस. 1 सेकेंड, नेक्स्ट वन. डेल्टा जी आ गया, इसको भी छोड़ो अभी. इसको भी. चले, फॉर एग्जांपल दिस वन, इसको. अच्छा, आई कैन रब दिस. अच्छा, फॉर एग्जांपल दिस वन. नहीं, ये भी कैलकुलेशन का है, मैं सिर्फ वो वाले करना चाह रहा हूँ, ये वाला कर लेते हैं. अच्छा, फर्स्ट वन. What is meant by the entropy of a system? It is the measure of disorder of a system.
It is
ठीक
the
है.
measure of disorderness of a system.
सॉरी, डिस्कनेक्ट हो गया था. ये बस 1-2 क्वेश्चंस और करते हैं इसके. चलिए, आवाज आ रही है.
Yes, sir.
अच्छा, हम थे यहाँ पे. अच्छा, इट इज द मेजर ऑफ डिसऑर्डर ऑफ अ सिस्टम, राइट. अच्छा ये बताओ, state explain whether the entropy change of each of the following processes is positive or negative. Do not consider the entropy change of the surroundings. The liquid water is from 80 degrees centigrade is cooled to 60.
Entropy negative. Entropy negative.
Positive.
Because the temperature has been lowered from 80 to 60. More disorderness. Yes, the particles come closer to one another. Lose kinetic energy.
They become more ordered. They lose kinetic energy and they become. Like 80 centigrade or 60, there's not going to be a massive difference. अच्छा वो कह रहा है solid calcium chloride is added to water and the mixture is stirred.
Entropy positive.
ठीक है, why is it positive?
Sir, I think the reaction is exothermic.
नहीं उसका उससे तो कोई ताल्लुक नहीं है, dissolve होगा ना.
Okay, sir, ये because it produces 3 moles of ions.
ठीक है, aqua science.
Sir, are we supposed to balance the equation?
I mean, yeah, this one, an equation always has to be balanced, ठीक है?
Okay.
Of dissociated aqueous ions. अच्छा, change corresponding to the lattice energy of calcium. अच्छा अभी lattice energy आप लोगों ने नहीं पढ़ा. I'm just going to give you the equation. Lattice energy is when gaseous ions.
Sir, when gaseous ions, 1 mole of gaseous ions, they will combine and they will form 1 mole of ionic solid.
नहीं, when 1 mole of ionic solid is formed from its gaseous ions. Gaseous ions जितने मर्जी हो. अच्छा, anyways, अभी उसमें नहीं पढ़े. This is the equation. So what is delta S? गैस जो है, धारा क्या होगा? गैस
Negative होगा. Negative.
ठीक है, it's going to be negative, right?
Yes.
So gaseous ions, they convert into are converted to an ionic solid. ठीक है, एक दो और देख लेते हैं वैसे. बाकी चीजें छोड़ें, just this thing. नहीं, forget this. आई बताओ, कह रहे solid lead oxide can be made, lead 2 oxide Pb plus 2, oxygen minus 2. Solid lead 2 oxide can be made from lead metal in air. ठीक है, तो ये solid है और ये half O2 gas. So क्या होगा? What is delta S? Predict the sign of entropy change.
Negative.
ठीक है, so that is negative because gas moles are converted into. Remember, एक ही mark होता है, converted into a solid.
Sir, what does it mean? 1/2 of oxygen. 1/2.
नहीं, वो balance करने के लिए ना 1/2 you can use 1/2. मतलब वैसे balance करो तो it's going to be ये होगा ना balance whole numbers में. ठीक है, तो चले ठीक है. ये पहला पार्ट क्लियर है सारों को कि मतलब we'll do more questions later on. अभी तो we just did the first part. ठीक है, बल्कि actually छोटा सा, we'll probably end up completing the whole chapter in the next class. ठीक है, entropy का. तो let's continue tomorrow then. ठीक है, चलें. Okay everyone, ये मैंने worksheet में तो send भी कर दी. Okay, Allah Hafiz.